Section 5 of Ancient Civilizations of Mexico and Central America by Herbert J. Spinden. This LibriVox recording is in the public domain. Read by Mario Pineda. Chapter 2. The Maya Civilization, Part 2. How Mayan History has been recovered. The arrangement of Mayan remains on a time scale is now an accomplished fact thanks to a correlation which permits us to read the dates on ancient monuments in terms of the Gregorian calendar and the Christian era. Early attempts to achieve this result met with widely varying results. Most of these attempts were made by developing a single line of evidence, and some were based on assumptions that can now be disproved. But no single line of evidence should be deemed sufficient to decide this all-important question. The general course of Mayan history is indicated unmistakably by four principal lines of evidence capable of being correlated with each other. These are 1. Stratigraphic sequences in pottery, stylistic sequences in sculpture, structural sequences in architecture, etc. 2. Traditional history preserved in the books of Chilam Balam and representing the knowledge of past events at the time of the Spanish conquest. 3. Dates inscribed on a great number of monuments in terms of the ancient Mayan time counts. 4. Astronomical checks on these inscribed dates. The artistic position of a monument may be used to validate the contemporaneous character of an inscribed date, otherwise interpretable as referring to the past or future, or it may serve to fix a repeating date in a single historical setting. The events in the traditional history of the books of Chilam Balam, meager enough when taken alone, have the valuable quality of reaching back into the time of the First Empire, when the use of dates on temples and monuments was much in vogue. They permit a richly documented past to be tied in, as it were, to a poorly documented terminal period. Before the matter of the ancient inscribed dates can be understood, however, the somewhat complicated mechanism of the Mayan calendar must be explained, as well as the system of hieroglyphs and the notation of numbers. Then there is the problem of correlation, which necessitates delicate adjudications of evidence. Finally, we must take up the proofs which demonstrate the astronomical achievements of the Mayas, which, in reverse, provide checks upon the correctness of the day-for-day correlation itself. We must proceed slowly and carefully, without much following of byways, however attractive they may appear. We will begin with stratigraphy and stylistic sequence. Sequences in art. The study of Mayan ceramics reveals developments as regard shapes, fabrics, and designs. Specimens recovered from sealed cysts under stelae at Copan establish true associations with the higher forms of art and can be used far and wide in comparison with pottery finds in Salvador, Guatemala, etc. Bioland has found stratigraphic sequences in a collection of funerary vessels obtained at Holmul, where graves occurred under the floors and within the filled-in chambers of a buried temple. As regards sculpture, we find at Copan a remarkably homogeneous series of stelae on which a royal or priestly personage stands erect and in front view. A ceremonial bar is held symmetrically in the two arms, and the body is partly covered with rich and elaborate ornament. The amount of relief, the proportions of the body, the forms of the ceremonial bar, etc., all pass through a harmonious development. The earliest monuments show a crude block-like carving of the face with protruding eyes, while the latest monuments have fully rounded contours. At Tikal, the stelae show, for the most part, human figures in profile, but unmistakable development can be seen in general quality of carving as well as in specific details. In making comparisons in art, it is always necessary to consider similar things. At many other Mayan cities than the two named above, it is possible to obtain satisfactory evidence of sequence in art forms by cutting out similar details from different masses. Thus, at Naranjo, when we examine all the ceremonial bars, we find a remarkable development of flamboyant detail on the later monuments. At Quiriguá, the faces on the tops of the altars may be compared with the same result. At Piedras Negras, the heads of the two-headed dragon that occurred in exactly similar positions of 4 monuments likewise show a steady modification towards flamboyancy, as may be seen from Figure 36, where the front heads are put side by side. Still, other lines of evidence on historical sequence are to be gained from a study of architecture. Not only it is possible to determine the general developments that hold true of the entire Mayan area, but also in a given city it is sometimes possible to arrange the buildings in the order of erection according to dependable criteria, both decorative and structural. The earliest temples have narrow vaulted rooms, heavy walls, and a single doorway. The rooms increase in width, the walls decrease in thickness, the doorways multiply till the spaces between them become piers and finally columns. The support for the heavy roof comb taxed the structural ingenuity of the Mayan architects. The solving of this problem is marked by successive advances, and since mechanical science goes forward rather than backward, the relative order of structures is fairly certain. Moreover, many buildings are closely associated with dated monuments, tablets, lintels, or stelae. Still, another evidence of architectural sequence is seen in structures that have been enlarged by the addition of wings or by the enclosing of the old parts under new masonry. Books of Chilam Balam. We now turn to a very different kind of history, the digests of ancient chronicles in the Mayan language, but in Spanish script, which managed to survive in these so-called Books of Chilam Balam, along with other texts, ceremonial or medical. There are 5 chronicles, the 2 longest covering 68 cartoons, before the coming of the Spaniards in 1517. We now know that these cartoons were time units consisting of 7,200 days, or nearly 20 years, and that they were designated by their final day, which was always a day called Ahau, associated with the number 1 and 13 in a peculiar sequence. A cartoon with the same designation returns in 13 times 7,200 days, or about 256 years. Such a completion, counted especially from a cartoon 8 Ahau, was called the doubling back of the cartoons, or, as we would say, the completion of a cycle. The count of the cartoons used in the chronicles was really part and parcel of a fuller count, just as the year 22 implies a position in one of the centuries of our Christian era. The chronicles unfortunately give few names of chieftains and cities and few outstanding events. Chichen Itza is the city most fully concerned, and an early occupation is recorded, then an abandonment for some 2.5 centuries. After its re-establishment, the Toltecs entered Yucatan and captured this capital. The first part of the chronicles had the atmosphere of myth rather than history, but a calendarial adjustment of some kind is mentioned in one place. This was an event which took place in 503 A.D., as we shall see in another place. The first rough correlation between the time count on the ancient monuments and the time count in the chronicles was made on the theory that a dated lintel at Chichen Itza had to be placed in the first occupation of the city. When this was done, the beginning of the chronicles was found to proceed from an important round number in the old day count, while the abandonment of Chichen Itza coincided with the abandonment of all the cities of the Mayan First Empire. We must now turn attention to the famous calendar. The Mayan time counts. The passage of time, seen in finer and finer degree in the course of human life, the succession of summer and winter, the waxing and waning moons, the alternation of day and night, the upward and downward sloping of the sun, and the swinging dial of the stars, are phenomena that no human group has failed to notice. Longer periods than those included within the memory of the oldest men, presenting an imperfect reflection of the memory of men still older, are found only in those favored centers where a serviceable system of counting has been developed. Mythology has a content of history, but hardly of chronology. Tradition, when organized by the priesthood, may be reasonably dependable for perhaps 200 years. The year and the month are the basis of all primitive time systems, the former depending on the recurring seasons, the latter on recurring moons. Both of these are expressed in days. Unfortunately, the day is not contained evenly in neither the month or the year, nor do these larger time measures show any simple relation to each other as regards length. The history of the calendar is one of compromise and correction. The Mayan calendars were made possible by, first, the knowledge of astronomical time periods, second, the possession of a suitable notation system, third, the discovery of a permutation system of names and numbers. Elements of the day count. There is reason to believe that the Mayas had first a lunar solar calendar of 12 months of 30 days each, making a year of 360 days, and that they reduced the number of days in the formal month to 20 and raised the number of months in the year from 12 to 18. These changes permitted a close adjustment of the units of time with their bagesimal system of counting. With a truer knowledge of the length of the year, an extra 5-day month was added to make the year of 365 days. Beyond this, the leap year error was calculated but not interpolated. As proof that the lunar month of 30 days preceded the formal month of 20 days, it need only be pointed out that the name for this period, Winal, seems to be connected with the name for moon, Yu, and that the hieroglyph for moon has the value 20 in the inscriptions and ancient books. Before entering into a fuller discussion of the astronomical and notational facts, let us turn for a moment to the third fact, the permutation system. The origin of this cycle, known by the Mayan name Tzolkin and the Aztecan name Tonalamatl, Book of the Days, has never been satisfactorily explained. It is a permutation system with two factors, 13 and 20. The former is a series of numbers, 1 through 13, and the latter a series of 20 names as follows: Imix, Ik, Akbal, Kan, Chikan, Simi, Manik, Lamat, Muluk, Ok, Chuan, Ev, Ben, Ix, Men, Siv, Kaban, Esnav, Kawak, Ahau. These two series revolve upon each other like two wheels, one with 13 and the other with 20 cogs. The smaller wheel of numbers makes 20 revolutions, while the larger wheel of days is making 13 revolutions, and after this the number cog and name cog, with which the experiment began, are again in combination. Thus a day with the same number and the same name recurs every 13 times 20 or 260 days. This 260-day cycle corresponds to no natural time period and is an invention pure and simple. It is the most fundamental feature of the Mayan time count and of the time counts of other nations in Mexico and Central America. We may perhaps assume that the 20 names were originally those of the 20 days in the modified lunar months, but the 13 numbers have no recognized prototype. The formal Book of Days generally was considered to begin with one imix for the Mayas and with a corresponding day for the other Mexican and Central American nations, but it can be made to begin anywhere and proceed to an equivalent station that is always 260 days removed. The conventional year. It has been stated that the Mayas arrived at a conventional 365-day year made up of 18 months of 20 days each, plus a short period of 5 days that fell after the 18 regular months had been counted. The Mayan month names are as follows: Pop, Uo, Sip, Sots, Sek, Sul, Jackskin, Mol, Chen, Jax, Sak, She, Mak, Kankin, Nguan, Pax, Kayab, Kumhu, Wajav, 5 additional days. Since there are 20 days or positions in the month, and likewise 20 distinct day names in the Tzolkin, falling in regular order, it follows that each day would always occupy the same month position were it not for the offset at the end of each year caused by the short Uayev period. As it is, any day name occupies the same month position during the course of an entire year and a position 5 days in advance during the course of the following year. Since 5 is contained 4 times in 20, there can be only 4 shifts, the 5th year showing the same arrangement as the first. The following table gives the month positions of each day name during the changes of the 4 consecutive years, as these are recorded in the ancient inscriptions. Ik, Manik, Eb, Kaban, 0, 5, 10, 15. Akbal, Lamat, Ben, Snav, 1, 6, 11, 16. Kan, Muluk, X, Kawak, 2, 7, 12, 17. Chikan, Ok, Men, Ahau, 3, 8, 13, 18. Imix, Chimi, Chuen, Ziv, 4, 9, 14, 19. Thus, Ik occupies 0 position the first year, 5 the second year, 10 the third, 15 the fourth, and 0 the fifth. While Manik that belongs to the same set has position 5 the first year, 10 the second, etc. It will be noted that Imix, the first day of the formal permutation of the Tzolk'in, is never the first day of a month. The calendar round. But this assignment of particular day names to particular places in the month does not close the problem. Each day name is associated in the Tzolk'in or permutation with a day number. While it is true that each day can occupy only 4 month positions in as many years, it must be remembered that the day numbers associated with these names can run the whole gamut of 13 changes. Thus, although Ik must always occupy the 5th position in the months during a certain year, nevertheless it will have numbers which fall in the sequence 1, 8, 2, 9, 3, 10, 4, 11, 5, 12, 6, 13, 1, etc. The complete cycle of variations must run through the least common multiple of 260, the permutation, and 365, the conventional year, or 18,980 days. This cycle is commonly known as the calendar round. A Mayan day fixed in a month, or let us say a calendar round date, has 4 parts to its name, thus 11 Ahau, 18 Mac. We describe a day as Tuesday, July 4, meaning Tuesday, the 3rd day of the 7-day week, occupies the 4th position in the month of July. Similarly, the Mayan date 11 Ahau 18 Mac may be read the day named Ahau as 11th day in the 13-day week occupies the 18th position in the month Mac. Owing to leap year corrections, the European date given above does not recur at regular intervals, but a Mayan day recurs infallibly in 52 calendar years, never sooner, never later. So far, we have considered 2 kinds of Mayan dates. First, the Tzolk'in date, recurring every 360 days. Secondly, the calendar round date, recurring every 18,980 days. Before we can understand a third and much more important kind of date, namely a date which states, in addition to the calendar round designation, the total number of days since the beginning day called 4 Ahau 8 Komhu, located far in the past, we must direct our attention to the matter of numbers and notation. Mayan numbers. The 3 most common numerical systems in use in the world are all derived from man's anatomy. The quinary system is based on counting the fingers of one hand, the decimal system on counting those of both hands, and the vigesimal system, which prevailed in Central America, is based on counting all the fingers and all the toes. The vigesimal system is seen in imperfect form in our count of scores, where 70 years are 70. The Mayan name for 1 was Hun. They had simple names to 9 and composite ones from 10 to 19, much as in English, and 20 was Honkal, 1 score. The ascending values in the vigesimal scale were as follows. Mayan numbers, Arabic equivalents. Hun, 1. 20 Hun equals 1 Kal. 20. 20 cal equals 1 bag, 400. 20 bag equals 1 pig, 8,000. 20 pig equals 1 cabal, 160,000. 20 cabal equals 1 quinchil, 3,200,000. 20 quinchil equals 1 allow, 64 million. 20 allow equals 1 hablat, 1,280,000,000. They invented signs for zero and discovered the principle of local value in the writing down of numbers centuries before these ideas, which are fundamental to higher mathematics, were known in the Old World. The notation of numbers had its simpler and more complicated phase. In the simpler phase, 1 was represented by a dot, 2 by 2 dots, 5 by a bar, 6 by a bar and dot, 15 by 3 bars, etc. The commonest sign for 0 was a shell, while a picture of the moon stood for 20. In the more elaborate notation, a series of 20 faces of gods represented the numerals from 0 to 19. The straight vigesimal system was doubtless used by the Mayas in ordinary counting, but in counting time a very important change was introduced in the third position. Also the names were modified. Han was called Kien, which means sun or day. In the second position, Cal was called Yuinal, which means month, and 18 of these were taken to form a tun, stun, which was then the third unit. The tun then had a value of 18 times 20 equals 360 days, making a conventional year about 5 1/4 days less than a true year. 20 tuns made a kaltun or katun, and above this period, the numeral system proceeded as before, and in the ascending values the names already given were merely combined with tun, if Gates is right in his clever suggestion. For years it has been customary to speak of the fifth period as a cycle for want of a native term. This will now be called Baktun. One Hablatun, the highest period with a name, has the astonishing value of 460,800,000,000 days. However, the highest numbers fall considerably short of this potential limit. In our decimal system, the number 347,981, for instance, is really 3 times 100,000, 4 times 10,000, 7 times 1,000, 9 times 100, 8 times 10, 1 times 1. When written out in a horizontal line, each position has a value 10 times that of the position to the right of it. It is understood that a digit which stands in a position is to be multiplied by 1, 10, 100, 1000, etc., as the case may be. The Mayas, using the principle of position, ordinarily write their bar and dot numerals in columns. But we can partially transcribe the Mayan number in imitation of our own system by putting dots or dashes between the positions or periods. The number in 5 positions given below is transcribed as 9.12.16.7.8. We read this date: 9 Baktuns, 12 Katuns, 16 Tuns, 7 Yuinals, and 8 Kins. It is convenient to remember that a tun is a little less than a year, a katun a little less than 20 years, and a baktun a little less than 400 years. But the count is really of days, not years. Although the numerical values are expressed by position alone in some cases, in other cases use is made of period glyphs to make assurance doubly sure. These period glyphs represent the basic value of the positions which are to be multiplied by the accompanying numerals. For examples, see figures 44 and 45. The long count. Many early monuments of the Mayas have inscriptions with an enlarged introducing glyph containing a variable element indicating the title or principal subject matter of the inscription. Next follows the number of elapsed days from the epoch of a mundane era. This starting point is uniformly the day 4 Ahau 8 Kumhu, and the complete initial series date not only states the number of elapsed days, but also the name and number of the day reached and its position in the Mayan month. The initial series is normally followed by a supplementary series, which concerns the lunar calendar, and often there are numbers of days to be added to or subtracted from the initial series date. These are called secondary series. Also, period-ending dates are used, these being merely abbreviated dates which correspond to indicated round numbers in the day count. The initial series analyzed in Plate 23 actually records the number 1,401,217. This number does not, however, reach the day 12 Caban declared immediately after it or the month position 5 Kayav recorded in glyph 10b. When 13 tons are corrected to 12 tons on the theory that the sculpture did not follow copy, we do reach 12 Caban 5 Kayav. Another check comes when we add this secondary series of 2,423 days and reach 4 Ahau 13 Jacks ending an even Katun. Dates of dedication. Initial series dates are especially common on stelae at cities of the First Empire, mostly located in the southern part of the Mayan area. While it is impossible to read much of the text which accompany these dates, nevertheless, it is a remarkable fact that when we arrange the monuments in their artistic order, we find that the inscribed dates in the great majority of cases fall in the same order. This leads us to conclude that the dates are practically contemporaneous with the carving and setting up of the monuments. Now, the above is especially true when the inscription gives a simple initial series date. When more than one date is given, the historic one appears in most instances to be the latest, but in a few instances it appears to be a specially emphasized intermediate date. In addition, then, to contemporaneous dates, there are some that refer to the past and others that refer to the future. Some writers have assumed that the stelae and other inscribed monuments were primarily time makers set up at the end of Hotun or 5-year periods. This seems an unnecessarily narrow view. We can demonstrate that some inscriptions deal with astronomical facts covering long stretches of time. It is also apparent that many of the sculptures represent conquests, and it is extremely likely that portraits of actual rulers are to be seen in certain carvings. It would be too much to expect events to happen regularly at the end of time periods, and as a matter of fact, we find at different cities repeated dates that do not occupy such positions. These repeated dates would seem to recall events of special importance to the city in question. The running coordination between the apparent order of the artistic styles and inscribed dates permits us to measure very accurately the rate of change in art, which was rapid indeed at certain times. The style of carving, on the other hand, enables us to put into definite 52-year periods many of the calendar round dates, if these are to be regarded as contemporaneous. The result is that for the First Empire, as it has been called, there is an exceedingly accurate chronology. After the fall and abandonment of the great southern cities, dates are rare, and we have to fall back upon remnants of history preserved after the coming of the Spaniards. Hieroglyphs. Mayan hieroglyphs resemble the Egyptian and Chinese hieroglyphs only in being sacred writing that is not based upon an alphabet. The styles and symbols are entirely different. No Rosetta Stone has yet been discovered to give us inscriptions in more than one system of writing in Central America. The great use of hieroglyphic inscriptions on monuments was characteristic of the earlier period of Mayan history, and at a later time the writing was reduced to books. Bishop Landa obtained what he supposed was a Mayan alphabet, but what he really obtained was a list of signs representing among other sounds the particular sounds he had asked for. The phonetic use of syllables rather than of simple sounds or letters is probably an important feature of Mayan writing. Many hieroglyphs are pictographic and consist of abbreviated pictures of the thing intended or of some object connected with it. Often a head stands for the entire body. The following list practically exhausts our knowledge of Mayan hieroglyphs. 1. the signs for the 20 named days of the calendar. 2. The signs for the 19 months of the Mayan calendar. 3. The phase signs for numbers from 0 to 19 inclusive. 4. Period glyphs in 2 styles for place values in the numerical notation. 5. The symbols for the 4 directions and for the colors associated with them. 6. The hieroglyphs of several gods and ceremonies. 7. The symbols of heaven and earth, the sun, moon, Venus, Mars, Jupiter, and a few astronomical phenomena such as conjunctions. 8. Hieroglyphs for special times of the year such as solstices and equinoxes. 9. Signs meaning era or base from which a numerical count is made, completion, etc. Some of these have recently been solved thanks to mathematical and astronomical calculations, others rest on the calendarial forms given by Landa. There are some phonetic elements in Mayan writing and some ideographic elements. It seems likely that the gist of the Mayan inscriptions which deal with history will be solved in somewhat the same fashion as those that deal with astronomy. The matter is, however, most perplexing. So far, not a single place name or personal name has been definitely recognized and translated. In spite of the hundreds of glyphs recovered at the sites called Copan and Palenque, for instance, we do not know the real names of these cities or even their symbols. We may expect to find signs referring to tribute and common objects of trade and others referring to birth, death, establishment, conquest, destruction, and other fundamentals of individual and social existence. These signs, taken with directives, connectives, and dates, would make possible the recovery of the main facts of history. There seems no possibility of purely literary inscriptions. While progress necessarily will be slow, there is no reason for despair, and without doubt the great portion of Mayan inscriptions will finally be deciphered. As an example of the phonetic use of signs in the building up of hieroglyphs, let us take the common sign kin, meaning sun. This sign appears regularly in the glyphs for the world directions east and west, the Mayan names being Likin and Chikin, and also in the month sign Yaxkin, and sometimes in that for Kankin. It also appears as the sign for the lowest period in the time count, having the value of a single day and called kin, figure 47. Now this kin sign also appears in many undeciphered hieroglyphs, and in some of these it seems likely that it has a phonetic value. Other signs with definite values in several glyphs are Jax, Tun, Sak, etc. This general method of writing is seen in more decipherable form among the Aztecs. The glosses of the early priests that have proved so great a help in the case of the Aztecan writing are absent from the few Mayan documents. End of section 5.